Around 9 years ago, I made a promise to a friend of mine. But it wasn't so much of a promise as it was a goal. And he wasn't just a friend, but my childhood best friend. And he suffered from a critical deformation following a tendon injury. But he's not the only one. Injuries pertaining to the hand account for 20% of patient visits to the ER annually, some even leading to the loss of functionality of one's finger. You know, growing up, we're taught to appreciate every organ of our body, mostly our heart and brain. But what people usually take for granted are the importance of fully functional limbs, like the hand. The hand is one of the most critical components of the human body. But just like any other body part, the hand is susceptible to many injuries, most commonly to the tendon mechanism. But the hand is no different to any cable-driven system that is used today. The motor, that's the muscle in the forearm, is connected to a set of cables, also known as tendons. These tendons stream through the hand and connect to the tip of the fingers, passing through anatomical tunnels, also known as pulleys. These pulleys function similar to pulleys in the mechanical world, where they not only reduce friction, but also convert any tension within the tendons to bending of the finger joints. So you can imagine how the tiniest or slightest disruption in this mechanism can affect the overall functionality of the finger. And the main problem is that when an accidental cut or injury leads to a full tear, surgical reconstruction of these pulleys is vital for restoring motion. And although reconstructions are performed widely across the world, 6% of patients still seem to suffer from complications post-op, such as stiffness, immobilization, or even a repeated tear of the reconstructed pulley out of the control of the surgeon. This raises an important question, which is, what do we do with the hand? How do we reduce these complications? Well, no one really knows. It was actually assumed by surgeons over the year that placing the hand in a neutral position will cause the least amount of strain to be experienced at the pulleys during rehab. But is that necessarily true? This is where my research comes into play. By designing a simulator capable of mimicking true motions on cadaveric specimens, information such as strain of the pulleys and tendon loads during finger motion were collected and analyzed with the wrist fixed in different positions after induced tear and reconstruction of the pulley. And with such a system, we were able to identify that placing the hand in a 30-degree flex position is the most optimal position for reducing strain of the pulleys. This information, however, contradicts to what surgeons believe nowadays. Yet, we believe that when we apply this in future clinical grounds, we will be able to reduce the percentage of patients that suffer from these complications, my friend included, from 6% to almost 0, by means of repair, rehabilitate, and restore. And that hopefully one day I can walk up to my friend again and say, I kept my promise. Thank you.